So kita akan memulakan kelas dengan Ummul Kitab Al-Fatihah. Bismillahirrahmanirrahim. Amin. Alhamdulillah. So saya akan mula share screen. So for today's new class, we will do topic 6. Kita dah masuk topik 6. So before we proceed, since I don't have the opportunity to discuss with you all untuk assignment, group assignment, if you have any question, before we start the class, you may ask now. Kalau ada apa-apa soalan lah nak bertanya. Siapa dah cuba group assignment, siapa dah attempt, siapa belum? Is there any problem ke? Anything that you like to clarify? Boleh tanya. Ada soalan tak? I do receive some personal message, tapi ada yang saya sempat jawab, ada yang saya tak perasan. Itu saya.
Boleh tolong explain.
Sorry, apa dia Fikri?
Boleh medium explain tak pasal sama?
Untuk ni, nanti towards the end of the class saya explain sikit take some time to explain on the assignment tu nanti So before that kita proceed dengan kelas dulu. So I'll do until OC curve nanti, okay, ataupun acceptance sampling, then I will stop. Then for today's activity, what I will do, I will continue with topic 6 in the class until acceptance sampling. Then I will stop there. I will proceed with the explanation of the group assignment. Lepas tu saya akan tunjuk sikit on the marking scheme that I have already, and then for your information, I have remarked all the test one though. So what are the marking scheme actually I'm using, okay? So saya akan tunjuk tu juga. I'll take some time, okay? So let's proceed in class dulu. So we have 26 students now, present now. So as usual, I would like you to log in your attendance using the view feature. Okay, macam biasalah. So, saya dah set dah. Kita nampak skrin saya ke?
Nampak.
Okay, yang ni view feature you nampak
Nampak.
So class attendance ni just as usual, you just log in your attendance guna view feature ni, okay? At the same time, I'm actually keeping track of your attendance using the Google Classroom. Google Classroom, Google Meet. Now I would like to share topic 6. So is there any question on topic 5 tak? Before kita proceed with topic 6 ni. Topic 6 is very important. Topic 5 is about learning cycle, Hoshin Country. It's about the implementation of the TQM, right? So it is actually exactly the question that I am asking you for your group project. Okay? So kita proceed dengan topik 6 dulu. Suara saya jelas ke sebelum saya mula?
Jelas.
Okay, baik. Now, TQM monitoring and controlling, this is one of the tools that mainly used for the process control, and then it is a part of the main task of the process engineer. Katalah insyaAllah in the future you will be enrolled, appointed as the process engineer, for example. This is one of the very important tool that you can use for the process monitoring. No doubt that each machine now is already being embedded with the SPC, okay? So right after they have conclude the machining operation, usually they can recall the data and then they can also gather the data from the machine. But you as an engineer, you need to know the mechanism behind those information. This is where I'm going to share with you how can you actually monitor your process, monitor the manufacturing process using the statistical process control ataupun SPC. So it's a bit of introduction on the statistics, okay? So these are the main, I would say that notation that you will see from time to time when you are dealing with the statistics. One of it is very important is the sample mean ataupun the average, sample average. In this case, in the statistical process, we use the X bar. As a layman term, we use the word average ataupun mean value dia. Okay, so we use X bar as a symbol for the sample mean. Okay, so X bar is the summation of the n sample size. Can be sample 1, sample 2, sample 3, sample 4 of the X value, And the small n, the small n here is actually referring to the sample size. So in the statistic, there are two main things that usually people will refer to. Satu dia panggil sample number, which is given by the notation ataupun symbol of capital N, and the sample size is given by the small letter n. So the one that you like to refer and then which is constant all the time, usually whenever you set for the SPC ataupun you set for the statistical activities, the sample size usually remain constant, but the number of sample atau berapa sampel yang you ambil can be varies. Okay, so sebab tu in most of the formula, they will refer to the sample size. Because usually we will stick to the same sample size, but you can have many sample number. Okay. So this is an example, just a very simple example of the mean value. Saya kecilkan sikit. Clear tak ni? Sekejap saya letak 85% kot. I want to see the whole page. Senang. Now, for the mean value here, this example is about the house prices in area KL, okay? So, you are interested in the typical house price, which is RM 100K, okay? So, the price were, so 2.7 is referring to 270K, yeah? So, you multiply dengan 100K lah, okay? So, this is the data that katalah you manage to gather for the housing prices in the KL area. Okay, so you ada 10 data sini. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's very simple for you to obtain ataupun to calculate the mean value. You just you just sum up all the data that you have gathered and then you divide by the number of sample tadi. So divide by 10. So the sample mean or the average house price is 710,000 here. Okay. So this 710,000 here is actually from the population of data. If you look carefully at your population data, all the data here is actually all less than 500,000 ataupun 500K. But because of this one particular value, harga dia 4 million, which is way out of the range that you have gathered all the 9 samples tu. Kita akan discuss this. Whether this mean value is actually the practical ataupun the good indicator for you to use or not. Okay. So let's look at next. So the mode of the data is the frequency, is the number with the highest frequency. So in this example, the mode will be 4.7 because it occurs berapa? it occurs twice in the sample, whereas the rest of the number or figure here, the value here, is only occurs once, sekali saja. So the mode will be a set of data ataupun a set of number with the value with the highest frequency. Okay, maksudnya dia occurs more than once ataupun dia lebih pada the highest number lah yang occurs. Okay, so in the above example, 4.7 is the mode since it occurs twice and the rest of the outcomes occur only once. So the sample mode in this example will be 470,000. So far okay And the middle score, if you had ataupun if you have the odd numbers in your sample size, therefore you take the middle number. You ambil yang the middle score. But in this case, since it is even number, therefore you take the two middles. So dalam case ni, you take the two middles, which is 3.7 and 4.1. So you add up these two number and divide by 2. That will be your median ataupun dalam case ni, middle score. So the median house price is 390,000. So mean or median? So dalam case ni, which of the value that you think it's more valid for you to adopt in your calculation? The mean value ataupun the median value dalam case ni? You rasa yang mana satu? Memanglah dalam ni dia dah jawab dah. You rasa yang mana satu? So, if you take a closer look at the data, the previous example shows that the house valued at 40.8 is actually 4 million. So this 4 million is actually skewed to the data to the right. Dia lari ataupun dia panggil kat sini the outliers dia. So usually whenever you collect the data, you have to be sensitive enough to identify the outliers, the number that occurs randomly, I would say that it's a wild number. Among all those distribution, this particular number is actually out of range, totally out of range. Okay, so the average house price of 710,000 does not reflect the price of the available house in KL area during that time. Okay, sample ni saya buat tahun 2019. Okay, this ni notes. So during that time, so in this case, the median house price 390,000 better reflects what house shoppers should expect to spend. So the moral of this discussion is that whatever numbers that you have already gathered, at the end of the day, it takes you to analyze those numbers and evaluate the number according to the present environment ataupun present condition dia macam mana. Okay, memanglah the numbers or data will lie, but it takes someone to come up with the more valid and I would say that realistic punya assessment. Now, how do you calculate the variance? Variance ni usually the difference between the standard number against the value that you have already collected. So, for example, katalah in your sample, the average value dia X bar. Okay, the average value X bar. But your, ataupun dalam kes ni, let's say you have a data sample ataupun the measurement value, katalah 10 plus minus 2 for example. So 10 will be your mean ataupun reference value. But your data collection can be varies in between those range. So to find the variance is actually the mean numbers ataupun your reference number, you minus with the actual readings that you obtain when you do the data measurement. Okay, so this variance calculation is given by this formula. So dalam kes ni S squared, dia panggil S squared is equivalent to 1 minus n minus 1. Okay, it's a summation of the x minus x bar value. Maybe perhaps in this form is a bit difficult for you to understand. Nanti kalau kita buat contoh nanti, it is much easier for you to grab the ideas. Okay. So variance of random variables ataupun probability distribution or sample is one measure of statistical dispersion. So the variance is actually for you, helps you to identify ataupun to evaluate the data dispersion. So averaging the squared distance of each possible values from the expected value mean. So usually dalam kes ni, ada siapa-siapa nak masuk, tak boleh masuk ke? If anyone would like to join the class and then having difficulties, please shout, please let me know. Because once I'm already in the presentation mode, I cannot see the screen of the Google Meet tu. So, for example, dalam kes ni, katalah you are, nak cakap apa tadi? Okay. When you are measuring the variance, sometimes this value can be a negative value. X sometimes smaller than the x bar value. But in the variance analysis, you are not actually focused ataupun your main concern is actually the value between the two figures tu, the variance tu, the difference. Yang tu you, regardless of the value kat depan dia tu, negative or positive. What is more concerned in this case is the difference tu. So you like to record all those information, data. So this formula somehow will eliminate the negative value tu by factoring the value tu, the square kan value tu. So bila you square yang nanti dia positif lah. Positif tu sure jadi positif juga kan. So faham kat sini how at the first place they are actually come up with this idea, because they nak positifkan those value. But in some example, you see that the mean calculation they based on the absolute-nya value. Bila the absolute value dia letak satu, dua bar kiri kanan tu, regardless of the value behind, depan dia tu negative positif, dia akan ambil only the absolute value tu saja. Dia akan refer tu. Faham So faham ni? Saya cakap seorang ni, saya tak nampak you all ni.
Faham.
Bagus. So the standard deviation to be, it will be the square root those value balik, then you akan dapat the standard deviation. So statistics ni very, the application dia very wide. Okay, so it is very interesting. Kita tengok example dia lagi, the proceed with the following content. So SPC ataupun statistical process control, it is a statistical evaluation of the output of a process during production. So the indirect monitoring of the conditions of the process by sampling the output. So indirect meaning to say that you are not measuring it directly from the machine. Of course, no doubt that the machine nowadays capable of recording those value, but in the actual value, for example, the one that you measure is only can be done by other process. So for example, the machine output, they can only monitor in terms of the number of outputs per day of that machine can produce. Okay, so just in terms of the numbers there, but in terms of the measurement, the variation in terms of one output from another is only can be done by other process. For example, the operator will go to the line and withdraw the sample, and then this sample he or she measures. Okay, so the measurement too is only done by other process. You can use the CMM ke to measure. You dah belajar kan, coordinate measure machine. for the complicated punya dimensions ataupun objects. But for the simple items, you can measure using the vernier caliper pun boleh. So the objective of the activities is actually to evaluate or to check whether the process is in control or not. Okay. So variation and control. So random variation is actually the natural variations in the output of process created by countless minor factors. So there are so many factors affecting the variation ni. So you may set the same parameter setting at the end of the process. In terms of dimension, it can be varies from one sample to another. So assignable variation is a variation whose source can be identified. So of course, no doubt that each factors varies from one another. But in most cases, these factors is actually the one that you are already anticipated to happen. I like to use the injection molding variation since you have already experienced in your MEM 564 the laboratories work manufacturing process. So from one part to another part, let's say you are using the injection molding machine. In the machine itself, you do set the parameters constantly. Okay, for example, temperature you dah set dah. That temperature, katalah 80 degrees Celsius temperature or 120 because nak melt the temperature ni kan 120 degrees Celsius with the temperature setting, and then your pressure setting maybe 2 bar for example, and then the cycle time ataupun the injection molding time, let's say 1 minute for each product. They will go through the same setting, and yet at the end of the process too, you will see several, or you may not see any rejects, or you may experience several rejects towards the end of the process too. So all those rejection is actually things that you perhaps you already anticipated. For example, ada silver streak ke, you ada nampak macam line-line macam silvery line tu, atau short ke because the poor pressure pipe ke, ataupun the material is not fully melted and yet you already start doing the injection process, so it will affect in terms of the flow of the molten material inside the mold. Okay, these are the things that you have already anticipated, and then you include in your defects criteria. But some of the things that yang you tak anticipate, yang ni dia panggil outliers tu, ataupun unassignable causes. Right. So the typical control chart. So this will be the typical structure ataupun typical development of the control chart. You will see the mean value ataupun dipanggil kat sini the average value, ataupun the CL dia akan letak sini, the control line dia. And then the upper control limit will be the range on the upper value, and then the lower control limit. Katalah you ada 10 plus minus 2, that means the upper control limit will be 12. The lower control limit will be berapa? 10 plus minus 2. 8 ya. So as long as your data varies within these two range values, then you can interpret that this data is ataupun this process is within control. Okay, so any variation in between these two lines, upper and lower control limit, it will be considered as the normal random variations. So anything yang beyond these two lines will be considered as the abnormal variation due to the assignable or unassignable causes. So kita tengok how do you develop the SPC. So SPC ni dia ada two types. Satu dipanggil variable control charts, another one is variable and Allahumma salli ala sayyidina Muhammad. Uh, saya lupa. Innalillah. Sekejap Ada dua. Okay, attribute. Sorry, by attributes. Variable control charts. Variable control chart is the value that you can measure and then you chart accordingly. The attribute types is actually you based on sama ada dia pass or fail. So most of the chart at the machine is actually follows the attributes control chart. So observation from sample distribution. Okay, katalah ni kan, since you take the mean value of each value tu sebenarnya, so whatever variation is actually the mean of those sample. Katalah sample number 1 ataupun dipanggil sample number. So this sample number is given by the big N. Okay, so sample number 1, every time you go to the line, you withdraw 5 samples. Okay, dipanggil sample number 1, you take N sample size, small n. So this N sample size is constant throughout the sampling activities that you do in the operation tu. So katalah pukul 8 you take the first sample number, pukul 8 pagi. So you go to the line, you take 5 sample, 5 specimens, okay? So you measure and then the average value you plot here. And then at 10 a.m., the next 2 hours, at 10 a.m., which is known as sample number 2, you withdraw another 5 samples. And so 5 samples or 5 specimen, kalau tak nak bagi you confused, 5 specimens, then you measure. So the measurement value tu, then you average out, then you plot here. So it continues, so on and so forth. Sebab tu sample size dia remain sama, but sample number can be more than according to your setting lah. Bila berapa banyak yang ambil. Okay. So faham ya? Ada jawapan. Now, dalam case ni, if you look at this example, dia letak the mean value is mu. Dia tak letak X bar. Why mu? They have reason why they put mu, okay? Mu means that the X bar value, the mean value here is actually based on the average value tu juga. So, mu or equivalent to the X double bar is the average of the average value. So, to differentiate between these two value, they put the mu value, okay? So mu is actually the notation ataupun symbol for the average of the average value. So sigma is equivalent to 1 because it is based on this population. Kalau tak tadi sigma dia letak the S-nya squared kan, standard deviation, okay? Case ni dia put the sigma value is equivalent to 1 dalam example ni. So when you see the process like this, cantik je, the mean value dia at 0, the mu dia kan at 0, and then the sigma value dia is equivalent to 1. That means this process is very much in control, sangat-sangat in control. So if the mean value has shifted either to the right or to the left, so it means that the process is already out of control. Kalau yang ni out of control, increase the standard deviation. Katalah standard deviation sepatutnya 1, now the data to disperse, range tu jadi besar. So it means here that the process is also out of control. Next. So far faham eh? So types of control charts. Basically, there are 2 types of control charts. Two is known as the variable control charts. So this control chart you can use for you to record and analyze the information that is measurable. For example, temperature ke, volume ke, the size, yang ada value yang boleh measure lah. Okay? So the mean value of this X chart, kita akan panggil the X bar chart, and then it will detect the shift of the mean. You need to use both. In this case, the X bar and R chart. Why? It is true for the variable control charts. Usually, you will monitor both X bar and R chart because the X bar will monitor in terms of the mean value to shift to the right or to the left. Okay, but the R chart will help you to monitor in terms of the data dispersion. Data tu disperse ke tidak. Okay. So control charts for attribute or discrete measures such as number of complaints, number of scratches ataupun number of defectives. So defect and defectives. If you look carefully here, P chart dia kata measures percent defective. Defective ni usually referring to the one particular product atau one particular sample yang have many defects inside it. Katalah you are actually analysing ataupun evaluating one part, nama dia the iron rod, besi, ataupun injection molding ataupun size parts of the, katalah iron rod lah, iron rod. So this iron rod must be in terms of finishing dia mesti nicely polished, no scratches for example, no dented, tak ada dent ataupun, and the size dia must be exactly 10 mm for example. So when you measure this particular part, katalah sample number 1, you measure. Sekali dapat ada scratches. So the same part also having a few dent, okay? Ada denting kat situ. Ada lubang-lubang ataupun ada penetration lah, lubang, okay? And then after you measure the part, you found that it is slightly shorter than the standard dia. Katalah dia standard dia 10 plus minus 1. This particular sample you measure, the measurement dia 8.5 for example. So it is already out of range. So this one particular part having several defects. Dia ada denting, dia ada dent kat situ, dia ada scratches, and then dia pun short of size. So this particular sample atau part ni is a defective punya item. So defective consists of several defects ataupun consists of only one defect. So defects may occur several ataupun one in one defective item. Faham ke tak? So faham tak maksud saya ni?
Faham.
Okay. So P chart ni dia measure percent of defective, okay? And C chart measures number of defects per sample. Because P chart ni usually dia refer to sample yang besar, and then dia untuk attributes ni contohnya katalah dalam satu lot sample tu of 200, how many from the sample size that they have taken tu, berapa banyak yang dia jumpa defects. But the C chart, okay, in this particular case, katalah you use P chart to find the defects tu, and then I'll show you the example why P chart is not is actually more realistic atau practical to use in the population ataupun sample size yang besar. Okay, C chart is actually another means of measurement that you can use to measure the number of defects in a sample. Okay. So ni contoh dia, standard deviation calculation. So when the process mean ataupun mu and standard deviation are known, therefore you can calculate the standard deviation of the sample means tadi. So standard deviation of X bar is given by this formula. The variation ataupun the sigma value divide by square root of the sample size. So you akan dapat the standard deviation of the sample means. Let's say this value is not given to you. No problem. Usually kalau this value is not given, you can the sample ataupun you can extract the value from the the normal distribution curve punya chart. Okay, nanti kita akan see that. Okay, so upper control limit is given by this formula. Mu plus Z is actually referring to um, the process capability that you would like to adopt. Okay, berapa persen? Okay, nanti kita akan tengok contoh dia. And then the S bar or the and multiply with the standard deviation. And then the lower control limit is LCL. It's equivalent to mu you minus with the Z value multiply with the standard deviation of the sample means. Okay. So X bar value here is equivalent to the mu value tadilah. Okay, sama. So here is the explanation of each of the parameters ataupun variables that you see in the formula tu. So X double bar is the mean of the sample means or a target value set for the process. So ataupun mu kat sini. Z is the number of normal standard deviations. Okay, can be 99.9% ataupun 6 sigma, 2 sigma, 3 sigma ataupun 6 sigma. Usually people akan guna. Okay, kita akan tengok example ni. And the standard deviation of the sample means is given by this formula, sigma divided by square root of n, and sigma is the population of the standard deviation. You can calculate sigma is actually can be obtained by the s squared u square root by the x minus x bar by d squared divided by n. Okay, so sample mean is n is the sample size. So let's look at the example here. So in this example, each time the sample mean dia atau the sample size dia is actually 9, 9. So this example is actually referring is about they measure the weight of the oat flakes ataupun cereals. Okay, so hour number 1 ataupun for the first hour ataupun for big N1, the operator went to the line and took 9 samples ataupun 9 readings. They measure kotak oat tu. Okay, so out of 9 sample, the first number ataupun the first sample tu, dia punya weight is 17 ounce. Katalah ounce dalam kes ni Mak Saleh punya example 17 ounce kotak pertama. So dia ambil yang second kotak pula, tengok ada 13 ounce. Okay, yang ketiga pula 16, so and so forth. And then they continue doing it until the 9 sample. So they average out, dia dapat the mean value here. The mean is 16.1. So this particular operator continue his or her task doing the sampling throughout the day. So each day dia akan ambil ada 6 sampel. Each of the sample consists of 9 sampling plan dia tu. Okay, each of the sample number tu, sample number 1, number 2, number 3, number 6 tu, dia ada berapa size dia berapa? Siapa faham kat sini?
9.
9 Dia ambil 9 datang maksudnya. Dia ambil 9 kotak cereal. Okay, 9 kotak cereal tu, each time dia measure the weight and then dia average out. Sebab tu dia dapat mean value dia. So dalam kes ni, dalam 12 jam, katalah shift pertama 6 hours, shift kedua another 6 hours. So throughout the day, dia ada 12 sample number. So dia measurekan. So the mean value of this mean ni, dia panggil apa dia? Dia akan averagekan balik. Dia divide by 12. Dia akan dapat apa dia panggil? X. Apa dia? Siapa boleh jawab sini?
X double bar.
X double bar ataupun the mu. Okay. Now dalam kes ni, the Z value is actually, they take the Z value of 3. So the control limits ataupun the Z value of 3 refers to the set 99.73%. So at any point of time, they are confident that their process will fall between this 99.73%. Itu assumption dia. So, just substitute into the formula to find the upper control limit value. The X double bar yang tadi tu, this value dia divide by 12, dia dapat X double bar, dapat 16 dalam case ni. And then multiply dengan control limit dia tadi 3. And here the value of ni sigma dia 1/3. Sigma dia kata tadi 1. And then 3 ni, how do they get the 3? Siapa tahu kat sini? The formula for the standard deviation for the mean sample size is actually given by standard deviation sigma divide by sample size n and dia square root kan. So sample size dia tadi berapa? 9 kan? So that's why dapat 3 ni kat sini. So 1/3. So far okay, faham kat sini ya? So the upper control limit is 17 and lower control limit is 15. Just substitute into the formula. Right. So in this example, the 9 boxes tu, sample tu, the mean value they distributekan over this. So this is actually based on the each sample size tu. Okay. So the mean value here. So in this case, it seems that sample number 12, sample number 11 and sample number 10, it is actually out of range. Out of range value dia. Terkeluar daripada range dia sebab reading dia berapa tadi? The mean value dia less to sample 10 and 11 tu less than 15. And then sample number 12 is actually more than 17. Kalau tengok ni 70.3. Yang ni 10 and 11 is 14.8, 14.2. So they need to look into the process lah. That's how you monitor the process. So you don't let this data on its own, you have to re-evaluate balik. Whenever you plot this data, you just need to come up with a decision what to do next. Okay, it seems that after 10 hours, the machine tend to run out of control. So they need to stop the next process and then look into the problem. Yang tu lah you buat decision tu. So now, so in this example, when the process mean mu standard deviation unknown, the standard deviation means of X bar value is sigma divide by square root n. So dalam case ni, sigma dia berapa tadi kat sini dia letak? (0.3). So square root, the n value is 9. So kalau macam tu berapa value dia? Standard deviation of the sample size, number of standard deviation is 3. Maksudnya Z value kat sini dia ambil 3, okay? So how do you, siapa boleh calculate value of the sample mean ni? Standard deviation ni, value dia. Standard deviation of sample means. Apa value dia? Sigma dia letak kat sini, sigma dia 0.3 divide by n, 3. So 0.3 divide by n, so 0.3 divide by 3. So berapa jadi value dia?
0.1.
So tak susah kan? Janji you faham je lah. Okay. So in this example, let's say the standard deviation is not given. And then for this case, you can use other approach. So in the case or in the event that the standard deviation is not given, you can use another formula to calculate the upper control limit and lower control limit. So it is given by these two formula, yeah. So upper control limit is equivalent to the X double bar, you plus the A2 R bar. How do you get the A2? Actually, you can obtain from the table. Nanti saya akan tunjuk table tu. So R bar is actually the range of the average of the range value in your sample tu. And the lower control limit is given by x double bar minus the A2 multiply with the range value. How do you get the range ni? Siapa tahu macam mana nak dapatkan range? Kalau dalam contoh ni, macam mana nak dapatkan range dia dalam contoh ni? Siapa tahu? The range is actually the maximum value of that sample size tu minus with the minimum value dia. So dalam kes ni maksimum dia berapa? Apa dia? 18 maksimum dia. 17. Okay. Dalam kes ni lah untuk range yang sampel nombor 1 ni, the highest number is 18 and then the lowest is 13. So 18 minus 13. So the range value dia untuk sampel number 1 is 5. Faham tak? Then the R bar, okay, again we using this sample. Katalah sini you calculated the range value as well. So you just put it here. Instead of mean, you letak R kat sini. R. So R value all. So R bar is given by the summation of the R value yang you have calculated tu, you divide by 12. So you dapat the R bar value. So now dalam case ni R bar will be given to you, nanti the sample dia. So R bar is the average range of the samples, and then A2 the control chart found in table 6.1. So tadi sampel kita berapa tadi? Sample size kita 9 So if sample size is 9, for the A2 value is 0.337. You kena ambil yang tu lah. Faham A2 multiply dengan R bar value. So R bar, tengok example ni dia kata, okay, dalam case ni example dia bagi sample size is 5 sample size is 5. So R bar value is given 0.25 and X bar is 12 ounces. So if sample size is 5, kita tengok dalam formula tu. Tengok, so X double bar is 12 ounces. A2 is taken from the table 1. Okay. Table 1 tadi kalau A2 value, kalau 5 is 0.55. Okay. So you just take this value, you multiply dengan R bar dia. So upper control limit is given by 12 plus 0.55 multiply dengan 0.25. So you akan dapat 12.144. So lower value dia, you minus this calculation. So it's 11.857. So you just letak sini lah 11.857, 12. And then the mean value is 12. So that's how you plot the plot the X bar chart without the sigma punya value. Okay, so far okay, faham Saya akan proceed lagi ni to the next ini. Now let's look at the R chart. The types of variable control chart shows example ranges over time. And then it monitors the process variability, the variation there. And then independent from the process mean. Dia tak termasuk dalam process mean tu, you monitor dia on its own, okay? But it helps you to make the decision. So how do you calculate the R bar value, okay? And how do you plot the upper control limit and lower control limit? So the upper control limit in this calculation is given by the, of course you have to include the R bar value lah. So upper control limit is given by D4. D4 also is actually obtained from the table tadi. So D4 you multiply dengan R bar, and the lower control limit is actually use the D3 multiply dengan R bar. Okay. So let's go back to the sample tadi. So in the previous example, the sample size is n. So for the D4 value for sample size n is 2.115. For the D3 value is 0. So you just substitute into the formula je. Okay. So you will obtain this value. Right. So faham kat sini ya?
Faham.
Bagus. So because dalam test nanti, this is one of my favorite questions. Saya akan bagi the value and then I will ask you to calculate accordingly. So mean and range dia. Why do we need to have, for the variable control charts, we need to prepare these two charts, the mean chart and the R chart. Okay, kenapa? Sebab the mean chart will help you to monitor whether the mean value tu shifted to the left or to the right, dia naik ke atas. Of which in this case, the range can be similar. Boleh sama range dia. Okay, the range can be similar, but somehow your process is already shifted up. Naik ke atas dah. Okay, kalau you are only using the R chart, you cannot detect this. Contohnya lah tadi 10 plus minus 2 for example. So kalau 10 plus minus 2, if your data 7 kat bawah, tapi your data kat atas pula, so 10 plus minus 2, that means range dia 2 lah range dia 2 lah kalau dalam case yang extreme lah. Katalah 12 is the maximum and 2 is the minimum, 8 is the minimum. So 12 you minus dengan 8. So you akan dapat 4. The difference will be 4, okay? Difference dia akan 4 dalam case ni. As long as it is within this 4, it is accepted. Katalah contohnya. But there are certain cases, kalau you are only monitoring the punya range dia sahajalah. If 13, katalah tadi 12 minus dengan 2, that means 4. Kalau data dia 7 and ke atas dia apa and then you are only monitoring in terms of dia punya range sahaja, okay? Kalau it means 12 and 8. Kalau 13 and 7 15 and 8. Contohnya kalau 13 and 8, okay, kalau 13 and 8, you will get the same range. Range you akan dapat 4 juga. But in actual, the sample mean tu dah already shifted up. Dah naik ke atas dah. So by monitoring the range as well as the mean value together, you akan nampak dia punya, you akan monitor dia punya overall performance tu. Okay. Sebab here you tengok kat sini, katalah walaupun dah shifted up, okay, katalah tadi example dia 12 and 8, that means 4 difference dia. But somehow data tu dah makin naik ke atas. But the reading yang below ni is actually remain ataupun within the range. Katalah kat sini sekali, last kali sini, let's say here is 14. Kalau by right 14 is already out of range, 14, but here 10. But 14 minus 10, you still akan dapat within the range. The R chart won't detect. Kalau you are only using the R chart kan, the R chart won't detect. Sebab dia akan dapat 4, 4, 4, 4 saja. Faham tak maksud saya? But the X bar chart will detect. Sebab dia dah start to skew to the right. Dia naik ke atas. Okay? So far boleh faham But if the data, they have observed ada increase in a dispersion, then the R chart able to detect it. Okay, R chart akan dapat detect. Okay. Contoh apa? Saya nak bagi contoh. Katalah 12 dispersion lah, data dispersion. So the mean value, katalah you divide by the mean value, still dapat constant, but the data somehow is already dispersed. Okay. Katalah average value dia, katalah dia ada 10, ada 11, ada 12, but in average you dapat sama mean value dia. Kata dia 14 and 10 14 and 10. So for ada 14, ada 10, but somehow after you average out, the X bar chart tu okay. But here if you use the R chart, you will see the dispersion value dia tu. Dia dah start tu lari dah kan. Tu maksud dia. Nanti kita akan cuba example in numbers, then only you can see the situation tu. Okay. So for the variable mean and range control chart. Okay. So in this case, saya tanya soalan sini, what is the sample size in this example? Apa the sample size in this example?
Five.
Sample size is 5. Siapa kata 5? Siapa kata 3?
Tiga.
Siapa kata 3?
Saya.
Awak kata 3. Siapa kata 5 tadi?
Saya.
Ini quite straightforward Siapa saya tu, nama apa?
Faiza.
Faiza. Faiza betul Faiza?
Ya.
Sample number. Okay, dia kata sini unit ni sample Sample number 1. Untuk first hour kata sample number 1 ataupun the rotation, the first rotation tu, operator pergi line, dia ambil 5 unit. And then they measure. So dia dapat average value dia 95.4. Faham? So the second hour ataupun dia panggil sample number 2, the operator goes to the line, then dia ambil measurement. 5 measurement juga. So dia average out the value, dia dapat 96. The range dia 2. So range ni, how do they get the range? So you find the maximum value in this number sample and you minus dengan the lowest value. So 95 minus 3 is 2. Here also the same. 97 minus dengan 95 dapat 2. Same activities. Katalah saya add on another sample, the mean value dia, you just find n unit sample size. So dalam case ni sample size is 5 So X bar double bar value, you average the mean value here. And R bar value, you just average the R value sini. So dapat 3. So to do the calculation, since the standard deviation is not given, so you use the the formula of the calculation without the standard deviation. Okay, so you just substitute dalam formula ni je lah. UACL X double bar A2 multiply dengan R bar. So R bar value you know dah already. R bar value is 3 and then X double bar is 95.07. Since sample mean is sample number ataupun sample size is 5, therefore the value of sample size 5 is 0.577. Okay, yang D4 dia 2.14, ingat ni. So you just substitute into the formula. So kalau you plot, you akan dapat ni lah. So upper control limit X double bar, you plus dengan Z value is given tadi berapa? Z value dia 3 kan, Z value tadi dalam kes ni. Oh tak ada, dia tak pakai A, sorry. A2 dengan R bar. So you multiply, you akan dapat ni. I would like you to try out this at home. You cuba. So how do you get this upper control limit value? And then how do you get this lower control limit value? Because saya tak masukkan dalam contoh sini. But since previously we do it in class kan. So I ask the student to do it, the calculation there and then in the class tu. Okay. So for R chart value, the nominal average value is 3. So for any negative value, you just letak 0 saja. Okay, faham ni bila you nak plot R bar or R chart, any negative value that you have obtained, you just letak 0. And the upper control limit range is 6.33. So according to the mean and range control chart, is the process is in control if this later sample was collected. Katalah saya tambah lagi satu sampel kat situ. Proses tu in control ke tidak? So, you nak kena buat macam mana? You have to recalculate lah ya. So, what you need to do, you add on this sample. Dia akan jadi sample number 4. Sample number 4, you letak tambah sini sample number 4. And then you just do the calculation. You recalculate everything. You recalculate the mean value, you recalculate the range value dia, and then you replot everything. Then only you can determine whether the process is in control or not. Okay? So far, faham ya? Before saya proceed dengan control chart for attribute ni, siapa ada soalan? Saya nak habiskan dengan ini. Siapa ada soalan? Ini nak take file sekejap. Kita dah lebih kurang sejam dah. Semua okey? Semua okey, kita continue. Okey, kita continue ya.
Okay.
Jangan tidur tau. Ini banyak masuk test ni. Control chart ni. Okay. So, for the attributes, it's actually the chart that used to monitor the proportion of defectives in a process. So, P is actually referring to the percent defectives. C chart, control chart used to monitor the number of defects per sample. Okay. Katalah you tak banyak sampel you ada 1 atau 2 sampel saja. So, you may use C chart. Because C chart will help you, ataupun you ada cuma 1 sampel je. 1 iron rod saja, but you have several defects in iron rod, okay? And then you would like to monitor that. You can do that. You can use the C chart. Okay? So use the P chart. It is used when observation of each unit can be placed into 2 categories, either or, good or bad, pass or fail. They're discrete based on discrete. Usually P chart kita akan guna for visual inspection. Visual inspection, the decision is only okay or not okay, pass or fail, good or bad sahaja. Faham tak? Pass or fail. So it refers to one complete items. Part ni reject. You tengok, oh, color dia lain lah. It should be green and yet The color is multicolor, so you reject. So pass or fail. So kalau functional test, you test the bulb lights on atau tak, pass or fail saja. Operate or don't operate. Okay, faham So you can use P chart. So the question, if the sample size is n, what is the number of possible outcomes for a given sample? So the number of possible outcome is finite. Kalau finite ni maksudnya can be calculated lah. Dia bukannya infinite Kalau infinite tu, that means sample tu tak practical. So dia kata, where and how can you use the P chart ni? Requirements dia, it must be of multiple samples. Sample tu kena banyak. And then it must be relatively large sample size. And dia tu, sample size should be more or equivalent to 20. Then only your result is, I would say that reliable. Kalau tak, dia tak practical. So for example lah, you ada 5 sampel. And then you would like to, you inspect, you check, you guna visual inspection lah. Out of 5 tu, 1 reject. Katalah you guna P chart. So 1 out of 5. That means 20% rejection. Ooh, that is big. What more if the sample is only 2? Kalau 2, 1 jumpa reject. So 50% rejection dia, which is not practical kan? Tak realistic in terms of the assessment method that you use tu. Tak betul. So in this case, you can either use, kalau you have a very limited sample, you can either use C chart, or if it is measurable, you use variable control chart. Faham So katalah kat sini, example dia kata, if sample size is 20, results can be found as below. If 0 defective, then P is equivalent to 0. Okay, percentage of defective. 1 defective, that means ada 5% kat situ. Kalau 2 defectives, ada 10%. So note that percent defective changes in the increment of 5%. So dia exponential banyak. So if the true percentage defective 0.3, it will never show up in the results. Therefore, P chart must use large samples. So kita perlukan sampel yang besar untuk buat P chart. So how to construct the P charts? Percent defective P is total number of defectives items divided by number of samples, total number of defectives. Katalah dalam sampel tu you jumpa ada beberapa sampel defectives. So you divide by number of sample. How many sample do you take? Divide by the sample size. How many sample? Then 1 sample, 2 sample. Dalam 2 sample tu ada sample size dia of multiple of 20 for example. Okay, kita akan do the example of the calculation. So standard deviation is given by this formula P ataupun sigma P cap ni is given by square root of average percentage multiply with 1 minus the average or mean value tadi, percent defective, divide by n, you square root kan dia. So upper control limit P bar plus Z value, the control limit factor, multiply with the sigma, and the lower control limit is P value minus the Z multiply with the sigma of the percent defectives. So in this example, let's say the mean fraction of defective is given, katalah berapa dia value, and then example ni, katalah if Z value is 2, then the Z control limit is 95.45%. At any time the confidence, your process will be operating within this control limit value. Maksudnya tu, your confidence level. And then Z is equivalent to 3 is 99.73. Maksudnya. Okay. So let's look at the example of P chart. sample of work of 20 clerks are shown here. So 100 records entered by each clerk were examined and number of errors counted. So the fraction defective in each sample was computed. And then for this example, you set the control limit of 99.73. Okay. So sample number 1. Dalam sample number 1 ni, dia jumpa 6 errors. So each sample dia ambil berapa size dia? 100 records. 100 records. Kat sini dia tak letak 100 tu then this is the style of the question you're asking juga. So you have to aware, you kena aware and sensitive dengan this type of question. Dia kata 100 records being entered by each of the clerk. Ada 20 orang clerk yang enter this data. So sebab tu dia ada 20 ni, sampel ni. So each clerk is actually key in 100 data. So dalam 100 tu dia jumpa operator number 1 ataupun sample number 1 referring to operator number 1, dia jumpa ada 6 errors. So 6 divide by 100, so dia akan dapat 0.08 fraction defectives dia. So operator number 2 ataupun known as sample number 2, dia jumpa ada 5 errors out of 100 data dia key in tu. So 0.05. So continues until the end. Operator number 20, dia check 100 ataupun dia key in 100 data juga, and then she found 4 defects. So 4 divided by 0 by 100 jadi 0.04. So total number of error just total up lah yang ni. So ada 80 error. So fraction defectives, total number of error divide by sample size. So total number of error 80 divide by 100. So you akan dapat 0.8. Okay. 0.8 kat sini. Fraction defectives dia. So kalau you campur ni semua pun, you akan dapat 0.8 the value dia, the fraction defectives. So next, for you to get the average p-value dia or the mean value, so you substitute into this formula. So total number of error, which is 80, divide by total number of records examined. So it is recorded by 20 operators, and the sample size is 100. So sample size you multiply dengan number of samples. Number of samples referring to the 20 operator tadi. So 80 divide by 100 divide by 20. So dapat 0.04. So the p-value, the mean of the p-value is actually 0.04. Next. Your next task is actually to calculate the standard deviation of the fraction defectives tu tadi. So substitute into this formula. The p-value you dah dapat kat sini, 0.04. So 1 minus 0.04, you multiply with 0.04, the p-value, divide by the sample size, and you square root dia. Dapat 0.02. So since the z value here in this case is 3, so substitute again into the formula to calculate the upper control limit. The p-value, p bar, you plus dengan z multiply with the sigma of p bar. So you akan dapat 0.04 plus 3 multiply with 0.02. So you akan dapat 0.1. Whereas for the lower control limit ni, you akan dapat negative value. Since negative value is not since you get the negative value, so you just take 0 as your reference. Dia letak kosong je lah. Okay. So P chart. So the P value tadi, P bar dia 0.04, you letak lah P bar dia. So upper control limit 0.1, lower control limit 0. So the process is, the 1 point here is actually out of 1. So it is considered as out of control, out of range. Okay. So far so good untuk P chart ni.
Yes.
Okay, now kita guna C chart pula. Macam mana nak guna C chart? So C chart, it is used when the number of occurrences per sample can be counted. You boleh kira, you boleh tengok ada berapa kat situ. So no upper limit on the occurrence of the number of occurrences. So the number of possible outcome is infinite, can be any numbers. So scratches, chip dance. So contoh dia lah bacteria pollutants per unit of volume, okay. Number of calls per day, number of complaints, okay. So, kita tengok contoh dia. C chart is very simple dia punya formula dia. So number of defects per sample. So is given by the C bar, total number of defects divided by number of samples. Berapa sampel yang ambil. Katalah number sampel dia berapa, defects berapa. So you akan dapat dia punya C bar value. And then the standard deviation dia just square root of the C bar value. Okay. So the upper control limit C bar, you plus the Z multiply with the sigma of the C bar value. And then lower control limit, you minus. So let's look at this example. C bar is the mean number of defectives. Z is the number of standard deviation. So the square root of the C bar is the standard deviation. So Z value ni is the control limit. It is applicable in any of the calculation though. Okay, as long as it is given to you. Usually we will give the student this value, and then what you need to do, just substitute into the formula and check which control chart is actually suitable for that calculation. It's either variable ataupun P chart atau C chart. Okay, unless it is mentioned to you to use which one. Okay. So kat sini katalah day 1 number of sample. Day 1, day 2, day 3. Kata the management of hotels has received several complaints for 9 days. Maksudnya sample size dia over 9 days, 9 periods ataupun 9 sample dia ada. So untuk hari pertama dia ada 3 complaint dia receive. Hari kedua tak ada. Hari ketiga ada 8. So using the formula to find the C bar value is actually number of complaints divided by number of sample. So 54 divided by 9. So you akan dapat the C bar value dia 6. Okay, average dia. So very simple calculation. 6, the sigma value of the C bar is actually square root of the 6 value. So substitute into the formula je lah. Okay, katalah you dah ready calculated, you tak payah guna formula ni. Z you multiply dengan standard deviation terus. So you dapat ni. So since there is no negative value in your, if you want to plot the chart, if you obtain the negative value, you just use 0. No negative, okay. So plot kat sini. So in this case, number of complaints still within the control. Maksudnya still acceptable lah the process tu. So use of P chart and C chart. Okay, so in this example, the question asks you to construct the P chart and C respectively. Yang ni you buat sendiri ya. Kena buat sendiri, you must try out. In the next class saya akan tanya you whether it is within control or not. Okay, since sudah tahu dah formula dia, tak susah ni buat ni. So let's recap the control charts. So control charts for variable, untuk continuous punya expression, you need to use the mean chart dengan range chart ataupun X bar chart. Untuk attributes, you can either use a P chart atau C chart. But P chart is more suitable for the sample with bigger sample size. Okay. C untuk calculate the number of defect per sample ataupun you have a very limited sample number. So mean and R chart. Okay, the mean chart is actually to measure if the process is skewed either to the left atau to the right, which cannot be detected by the R chart. But the X bar chart alone cannot detect the sample dispersion. Okay, sample tu dah disperse dah range, but the mean value still shows within the mean value. That's the problem. But the R chart can detect that. Okay, use the R chart to detect the sample dispersion. So managerial issues and control chart. So 3 major management decision. So select points in the process that need SPC, determine the appropriate charting technique, set clear policies and procedures. Maksudnya kat sini, well, if you are planning to implement the statistical process control, you have to identify which process is actually suitable for you to come up with that activities. Okay, so the process must be measurable, and then it is continuously throughout the day, and then you can set the process to, and then it must be easy for you to monitor the process. Okay, kena mudah. So usually the best example is always, katalah you are monitoring ataupun you like to monitor the process at one machine. So the operator has to record the data, and then the operator, if the machine is not being equipped ataupun there's no system yang embedded to calculate the number of outputs, the operator has to record the data manually. Maksudnya every sample data tu dia akan tengok reject ke accept. And then dia akan record lah 1, 2, 3, 4 dan slash. And you have to determine the appropriate charting techniques. Macam mana nak record those data, those information. And then dalam case ni, I need to use either P chart, attributes control chart ataupun X bar chart. You have to determine that. Simple as that. Kalau based on percent defective, visual inspection, based on numbers, pass or fail, you use P chart. And if it is measurable, then you use X bar R chart. So set clear policies and procedures. Maksud sini, you have to determine how many samples that you want to take, the sample size dia berapa, and then the frequency of inspection tu, ataupun the sample number tu. How do you plan that activities? Katalah you based on by hourly basis. So that means sample number 1 at 8 AM you ambil berapa sample size dia. The policy and procedure must be clear. Okay, how are you going to do it? Okay. So variable data as per chart. Okay. Ini kita dapat dah. Attribute observation are attribute that can be categorized in 2 states. Good or bad, pass or fail. Macam tadi lah. Okay. So usually kita akan guna untuk observe the visual inspection, benda yang just right or wrong saja. Okay. Functional test. Okay. So patterns in control chart, saya tunjuk sikit. So this behavior, since upper control limit still within the upper control limit, so you know ataupun you can give the conclusion that this process is in control. Okay. So anything that is beyond the upper and lower control limit, you can say that the process is out of control, and then you need to investigate for the cause of the problem. Okay. Here, the trends here, katalah if you notice that ada 5 progressive here, it is within control limit, but somehow progressively ada 5 data ni they either going towards upward ataupun going downward. Then you need to investigate the pattern kat sini, what's wrong with it. It must trigger you something. No doubt that dalam case ni, if you look at this example, it is within the control lagi. but somehow the trend, you kena tengok trend, you kena sensitive lah. So all this actually it takes someone who has the experience based on their punya observation. Then you must alert at any time. You must alert whenever you see this kind of trend. Maybe you should aware something maybe not right is going on. And then here dia kata kat sini you tengok ada two plots very near lower at the either lower ataupun at the very upper tu. Dia dekat-dekat tapi kat sini je. Maybe there's something wrong with the setting ke ataupun is already worn out ke. Okay, you have to check lah. Maksud this character ataupun trend like this, you have to bear in mind, although it is still within the upper control limit, but it is actually the anticipation tu, it may lead to major punya problems. Okay, you have to be sensitive and aware. You have to be alarmed. Okay. What more if you see trend like this? Okay, dia naik ke atas je, above the central line. So it's about time for you to investigate. Perhaps there is an issue behind this trend. Okay. So yang ni erratic punya behavior ni, atas bawah, yang ni that means you have to investigate also. This is the kind of behavior in your plot. Okay. So I think I will stop sampai process capability. Okay. Because process capability ni I would like to explain in a bit detail because it is quite important. And then process capability ni, it helps you to measure the process, whether it is capable, and then what to decide next. Okay, by doing the calculation, by analyzing the process capability, it helps you to set the process specification, the machine specification, whatnot. Ada banyak benda yang bantu you. Okay. So far ada soalan sebelum saya pergi kepada explanation on the assignment. So you nak take 5, nak break ke atau nak continue? Kita habis cepat. Kita boleh habis cepat. Kita proceed. Mengkat jawab sini. Okay. Ada soalan tak? About the topic 6 until process capability. Any question?
Lupa tak ada.
Kalau tak ada, saya nak proceed dengan ni ya. Assignment. Group assignment tu. Okay? So in this group assignment, siapa dah buat? Siapa dah attempt? Be honest.
Baru bincang.
Baru bincang. Okay. So, in your discussion, what do you do? Saya nak tahulah apa yang you faham. Without getting any explanation from me, what do you understand? Because I would like to improve also the way I assign the question to the student. I would like to improve. I would like to get feedback from you. So, siapa buat tadi? Siapa baru bincang tadi? Pak Izzah ke?
Ya saya.
Okay. Apa yang you faham daripada assignment ni?
Macam kena buat mind map pasal 14 Deming points tu.
Deming 14 points. Lepas tu, lagi apa you kena buat?
Dengan yang reflection tu je lah. Tapi kita orang tak totally faham pasal apa yang kita buat semua.
Apa yang you tak faham? In particular, apa yang tak faham? How to start? Okay, tengok pada ni ya. The question is quite straightforward, saya katakan. I would say kan. Let's look at the instruction instruction dia. So concept mapping tu itself pun, do you know how to get the appropriate tools ataupun instrument to plot the concept, to map the ni concept mapping ni, to do the concept mapping? You boleh guna software mana, you tahu dah? Have you decided?
Not yet.
You boleh guna e-draw. Dalam e-draw tu ada function concept mapping ataupun any other available software in the website yang free punya, banyak ada. Okay, boleh guna. Okay, so as long as it is actually based on this definition, and then whatever that you do tu betul lah. Dia kata kat sini, concept map is a visual representation of knowledge. You ada maklumat, tapi maklumat tu dalam bentuk deskriptif, okay, description. But now you like to visualize, guna this mapping. Visualize to show in terms of dia punya logic dia, connection dia macam mana. Okay, from one point to another point. In the slides form, you cannot visualize, you tak nampak because the information tu terputus from one slide to another slide. But by doing the concept mapping, it helps you to show the relationship and then to connect all this information in one piece of paper. Okay, it is much easier for you to understand and link up all those information. Okay, dia kata apa? So the process enables the student to organize and structure the information and show the relationship between them. So this may be done in a wholly graphical manner using images, photos pun boleh, colors to highlight on the certain issue. Okay, so the linkages tu pun you can also highlight in terms of the importance dia. Okay, big arrow, small arrow, okay, the sub. Okay, so instruction dia. So Deming 14 points is a philosophy and the guidelines for the TQM. So students are required to work in a group of 5 members or less and construct a concept mapping of the TQM implementation using the Deming 14 points. So the core, the heart will be the TQM implementation. The how-to will be using the Deming philosophy. Faham tak guys? The core will be the TQM implementation. The how will be the Deming 14 points. Also, the student must reflect their learning experience. So, ada tanya saya, ada PM, what experience, madam? Your learning experience using the concept mapping. So, you have to express in the description yang mana. You describe it. What is your learning experience? Whether the concept mapping ni helps you to better understand the subject matter or not. In which manner, in what way it helps you. Cerita lah. Okay? Explain. Okay. So, to know ataupun to have a better idea on how to come out with the concept mapping, you need to refer to the rubric assessment dia. Okay. So, what are the things that I will measure and grade accordingly? So, saya akan tengok dari segi dia punya layout of the concept mapping tu. Whether it is well organized or not, it follows logical format. Logical format in this case, whenever I look at the concept mapping tu, it gives me the idea terus. This is my mapping, the format dia tu. Logic lah, bukan berterabur lah. Okay, bukan just simply you just do it out of you rasa nak buat macam tu. No, you must follow certain logical format. Okay. So it contains main concept dia tu. Apa dia? Of course, the Deming 14 points lah. Okay. All keywords and concept necessary to promote an overview of the unit are used and well organized to give the added meanings. So you kena organize accordingly. So for the layout organisation, saya bagi 2 skor dia. For the content, concepts and terminologies, you have to elaborate each of the point and show the sub point dia tu, content dalam tu. Deming 14 points kan ada 14, all the main points. You have to elaborate and show the connection dia. Okay, shows an understanding of the topics, concepts and principles, and uses appropriate terminologies and notation. So no misconception ataupun errors are evident kalau you nak dapat yang exemplary 4 points tu. Okay. So the connection and knowledge of the relationship among the concepts. So yang ni dapat 2 points. You must show clear connections from point number 1 to point number 2, whether is there any connection tak? If there is, then show how do you connect from each point tu. So reflection critically reviews the existing knowledge and articulates new perspective because of your experience tu. Because of that learning experience using the concept mapping. Because previously, what you do, you only report. Okay, you deliver your assignment in a reporting style of format. But now, instead of using report, I ask you to use the concept mapping. So I would like you to share with me in terms of your experience in using this concept mapping in delivering your assignment. Okay, in doing your assignment. So whether it is helpful, whether it is useful, whether it is gives you better understanding, gives you better ideas in terms of the networking, the linkages, those things lah, you explain. So faham? Cara you nak bagi kerja is up to you, it's up to you. Okay?
Madam,
Ya saya.
nak tanya, so at the end of the day kita kena hantar satu helai kertas ya, ada konsep map macam tu.
Ya.
Okay.
Can be satu helai kertas ataupun you bagi saya dalam bentuk soft copy. Katalah you have done this in a group, katalah your group members prepare several points, another several points, and at the end of the day, it takes someone to link up all of those information tu. You can put in the bigger picture pun boleh, and then lepas tu you can have the sub-subnya tu pun boleh juga. It's up to you. I like to see your creativity in addressing the issue, in answering the question, in attending to the problems tu. Saya nak tengok macam mana you. Because this is my first time also assign the student to in my assignment to use the concept mapping ni. Okay. But I have done this many times, but as a group activity sahaja in the class. It works. I would say that in terms of the effective, it is very effective. But now I would like to explore in terms of the giving assignment to the student and as a group assignment. Saya nak tengok how it works juga in terms of dia punya kata apa, effectiveness tu. Okay? So far okay ke? Ada siapa soalan lagi? It is almost 4. Saya akan continue dengan a bit of explanation on the test 1 punya answer. Okay, saya dah marking semua. Sebenarnya saya tak boleh nak return pada you all officially, but I was made to understand that student can access to the answer script tu dalam Google Classroom. Siapa dah tengok? You boleh access tak?
Dapat dah.
Dah minta tengok.
Dah tengok, okay. So, kalau macam tu, I would like to share with you the how do I grade your test 1. Ni nampak clear? Dekat sini, soalan 1 Soalan 1 tu memanglah saya tanya you according to ni. My question is actually how do you apply this principle yang based on the customer needs if you are buying a car. So I give you the point. If you are able to highlight that it able to satisfy my needs katalah your present need as a student, you need the economical car yang very low consumption, small car, easy to use, easy to drive in the campus ni, you explain lah. And then ability to of the product after sales service, it satisfy your needs, it delights your needs. And then lagi satu saya tambah sini, why do you need the transport? No, you have the absolute reason now because of the pandemic. You cannot take the public transport, so you need to use your personalnya transport ataupun personal punya ni. So those are the reason. Kalau bagi this point with explanation, dapat 10 marks. Okay. And then here question 1B, it is about the TQM. And then I am putting it in terms of the IR 4.0. So I want you to suggest how the TQM practitioner to stay competitive and cope with the IR 4.0 challenges. So you have to look from the manufacturers ataupun organizationnya point of view. Katalah you are an engineer in that company, how do you look into that issue? Because saya tanya sini TQM practitioner tau in an organization. So you have to reflect. So if you want to stay competitive in the organization with the IR 4.0 challenge, you have to assess dulu how to stay competitive. You have to assess your current punya readiness. Okay. So kalau saya nak tengok, and then you have to align, lepas tu strategize how to cope with that IR 4.0 strategy. And then how to get all the stakeholders, how the employees in the organization to be involved in the activities. So how to communicate with all the employees. So create values real time ni. So ada yang dapat full mark tapi tak ramai ya. So question number 2, it is about the company who like to implement the smart factory and with the TQM principles. Okay, this is only the scene setting here. But the actual question is deliberate the approach that the management must take to strategize their operation. It is about the strategic planning. Ni soalan dia, keyword saya dah. Has to take atau must take to strategize. So kalau you jawab mengenai the strategic planning stages tu, step tu, then you get full mark here lah. Strategy for the smart factory management. Strategy planning for the smart manufacturing. And then strategy development. Okay, ni jawapan dia. So answer B, soalan dia, yang B question pula, show how the management can align their organisation against the new smart factories operation. Is the organisation alignment against the employee dia, against the strategy. Yang ni kan ada ni, organizational effectiveness strategy dia, organizational alignment, maksudnya organizational structure dia against the strategy. Pakailah yang ni, kalau bapak yang ni dapat full mark. Tapi tak ada siapa dapat full mark kot. Ada yang dapat close 4 marks. So the management can align the organizations against the new smart factory operation using this model, organizational strategy versus the organizational capability alignment test. So you bagilah alignment. So question number 3, for this group, I would say that saya tak ada banyak masalah. Cuma some of you, even we have already done the same juga assignment in the same style of question in your assignment, and yet ramai juga yang tak bagi yang I would say that appropriate answer. Macam lightweight, strength of the backpack. Ada yang jawab strength should not be, the weight should not be more than the student's weight. How do we know the student's weight berapa? You must set, you must numbers, you must put figures. And then lagi satu, grade and color dyes. Ada yang some of you, sekejap eh. I call you back. I call you back, okay, tengah kelas. Okay? Okay, bye. So, some of you jawab, light colours. Light colours, colour apa? You tak boleh letak lighter colours, you tak boleh letak macam tu. You kena letak the dye colour yang exact colour. Okay? Exact colour, kalau light colour, pastel, cakap lah. Pastel, blue ke, pink ke, yellow ke, but pastel. Yang tu baru boleh. Kalau light colour, you bagi instruction to the operator, to the, katalah the dye house ni orang. You letak light colour. Lah, light colour apa? Dia nak you bagi tahu colour apa. So this is the situation. Bila you letak the specification, especially on the technical specification, it must be exact. Dia kena tetap. Dia kena betul-betul exact lah. Okay? Kalau grade pun, katalah dalam kes ni, you put in terms of the material grade, you have to put the grade dia. Grade A ke, grade B ke, nylon grade A. Contoh, letak nylon saja, but nylon so many grade, so many categories. You must put grade A ke B. I'm not asking you to put exactly macam yang sepatutnya. I want you to put something that indicates your understanding. Kalau you tak jawab properly, tak letak, you just kata nylon saja, saya tak bagi markah lah. Saya bagi pun satu je sebab CP. Okay. So, itulah dia. It must be here. Macam ni contohnya, contoh jawapan dia. The question kata determine the list of technical requirements related to the design and customer requirements. Design requirement kat sini. Saya dah bagi dah jawapan dia sebenarnya. And then dia kata name this list as table 2. Macam ni. List of design and technical requirements. It's already given tau. Cuma some of you macam blur-blur, tak buat betul juga. So, katalah number of zippers compartment. Padahal saya dah letak sini. Design requirement number of zippers. So, what you should do, just letak je lah. Kalau number of zippers, katalah you kata ada 3 zippers, 2 compartments. Pun boleh, saya accept. So, weight ataupun size of the backpack. Some of you give the size. Betul. Some of you give the weight of the backpack tu. Ada yang letak 300 gram backpack tu. Ya Allah. 300 gram, you just imagine. Dia punya sekerat backpack 300 gram tu. Agak-agak lah kan. Nak letak pun biar dia orang kata apa, realistik. Ni jenis yang kabel size kabel 60 meter. What do you mean 60 meter kabel size? Tali kabel tu 60 meter. Kalau 60 cm tu make sense lah. 60 meter tak realistik lah kan. So strength of the backpack tu, you kena letak loads dia. 10 kilo ke, 12 kilo ke contoh. Grade ataupun color, kalau you letak color, you letak. Kalau pastel color, blue, yellow, pink, kena letak. So price range ni can be price of the material ataupun price of the bags tu. Saya bagi betul juga. So here propose a suitable relationship ratings, use the HOQ. Ramai yang betul yang ni. Cuma you tak letak satu jawapan lagi, justification of your decision tu. Kalau setakat betul ni saja dapat 7. Ni satu markah, ni satu, 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 7 markah. If you include the justification, dapat another 3 marks. So 4 marks. Okay? Dah. Tu faham semua? Dia saya.
Nak tanya pasal group assignment tu boleh?
Boleh?
Kalau saya nak share screen boleh madam tunjuk kat madam?
Boleh. Saya stop sharing kat sini. Stop presenting.
Nampak madam?
Belum. Sekejap.
Yang macam madam cakap yang satu just buat konsep map tu, maksud madam yang macam ni yang satu page je
Masuk konsep mapping kat sini, cuba you Google konsep mapping.
Ni kalau macam yang kita orang buat ni macam macam ni, macam 14 damming point tu dalam satu konsep map macam ni
Saya nak you break down lagi the elements tu.
Oh ya.
Breakdown lagi the elements. Kalau macam ni tak payah buat group assignment.
So
Tengok dia punya instruction tu. You kena breakdown lagi elements tu.
Maksud madam breakdown tu macam kena explain lah apa tu.
Yes. Yeah.
Macam yang macam ni yang kita orang macam explain point-point tu macam ni
You letak dalam yes.
Oh, letak sekali
You letak in the point form dia. Because saya nak biar benda ni in one
report lah macam tu.
Yes, in one concept mapping tu. Yang ni nak bagi no problem as the additional ni tu. It's okay, boleh bagi. But I would like to see in the concept map tu itself.
Benda ni macam dalam concept map macam tu.
I don't want to see all this description in detail banyak-banyak ni. Saya nak you bagi point-point je dalam tu, the main point je.
Oh.
Yes.
So macam dekat map ni macam ada point-point dia macam tu, point.
Yeah, ada sub lagi. And then you highlight which one is actually related to which one. You can use the color coding ke. Also can. You can direct link pun boleh.
So just macam konsep map tu dengan yang explanation ni, betul yang intro tu tak payah macam.
Intro?
Macam buat macam report lah macam tu. Tak payah.
Saya tak suruh you buat report kan. Saya suruh buat concept mapping.
Okay. So
Faham
macam
soalan? Faham soalan, tengok dia punya rubrik.
Okay. Jadi nanti kami betulkan balik.
Yes.
Okay.
Supporting document you nak provide, yes. But you don't give me full report. Saya tak nak report. Saya nak concept mapping dengan supporting document apa-apa yang relevan.
Okay, ada.
Okay.
Thank you, madam.
Okay, no problem. So kalau tak ada apa, make sure that saya just share screen sikit. Saya nak tunjuk you where you can get the example of the good concept mapping itu. So before you do, you must do some homework. You buat homework, you check lah dalam website pun banyak. Saya tak ada petik benda ni daripada from the sky ke tak. This is all available. Okay. Nampak tak image ni? Nampak. So you tengok-tengoklah dalam ni kan macam-macam ada style ni. Katalah saya letak apa images lah, saya tengok images tu. Kan? Pilih yang mana yang ni yang boleh give you good punya representation for your exercise. Kata you ada macam ni, you ada central topic, you buat ni. The moment you tengok ni, tahu kan yang ni kan memang macam ni, you letak launch meeting. Tapi yang ni you letaklah agenda apa, make it interesting and orang kata you boleh ingat.
Madam, ni
Saya
let's say kalau macam kita bagi satu konteks kan, contohlah macam kita bagi satu situasi macam kita nak pergi pen contohnya, and then buat teachers, apa tu boleh ke guna konteks tu, kena ikut yang Deming points.
saya suruh you guna Deming 14 points.
Memang guna Deming 14 points?
Yes, Deming 14 points. Saya suruh you guna filosofi tu. Memang ada macam-macam, tapi saya suruh you pakai itu. Because kalau you buat inline pada yang tu, how do I compare your work dengan others? So if I were to compare, I have to compare between apple to apple, between the same exercise, between the same thing. Nanti kalau saya tak suka yang you buat tu, unfair to you lah, because you tak follow instruction. You have to follow the instruction. Guna Deming 14 points. Okay. So kalau tak ada apa, tu saja kelas kita. Make sure that you log in your attendance. Saya nak tengok je attendance, siapa dah log, siapa belum. Okay, ada a few lagi belum ni. Please do so Ke tak masuk kelas? Mama Adib. Adib tak buat lagi ni Adib Tadi tanya soalan saya tahu you ada. Ali Mimran, Firdaus. Okay, Pak Izzah tak log in lagi attendance Pak Izzah.
Okay, madam, saya buat.
Okay, just buatlah So, kalau tak ada apa, so kita end our session for today's class sampai kali ni. And then kita akan continue for the next class with the process capability and with some example of process control. Okay, saya akan bagi the class activities as example tu maybe before the class ataupun during the class hours tu. Kita akan buat sama-sama lah. Okay, with that saya end the session dengan tasbih kafara dengan suratul As. So, saya akan stop presenting. Assalamualaikum warahmatullahi taala wabarakatuh. Saya akan stop the class juga.
Assalamualaikum.
Thank you, madam.
Thank you.
Sakit.
Thank you, madam.
Okay, thank you.
Madam,
Saya?
kan yang group assignment ni kan,
Ya.
semua ada 8 group. Semua ada ada 4 member, tapi saya dalam group 2 ni memang 3 orang saja. Memang akan cukup 3 orang saja.
You 3 orang je, kenapa tak cukup
Yang ni semua 4 orang.
4-4-3?
Ya kan semua ada 9 group. Yang group ada 8 group. Semua satu group ada 4 member. Saya ada 3 orang. Memang akan kekurangan seorang.
Kenapa? Kan ada 32 kan ke?
Mungkin ada student yang tak ada group lagi kot, tak tulis kot, saya tak
8 kali 4, 32 kan?
Semua 32 sepatutnya kan.
Cuba masukkan dalam WhatsApp group. Siapa yang tak ada group suruh join you je.
Okay.
Okay, kena berbual tu. Kan kata tertinggal kan last minute nak suruh saya cari pula. Memang tak lah.
Okay.
Okay. Thank you Zat.
Okay.